So we are seeing something about quadric surfaces. What is happening here? Those objects which will have second degree equations, they will be considered as quadric surfaces. Okay, a little curve they will represent, right? They will not be mess of polygons. Okay, they will be able to represent the curve. That is the best thing. Simple objects like spheres, ellipsoid, torus, parabola, hyperbola, these things you would have seen, and they can be easily represented with their equations. Okay, whether it is a sphere, this is the equation, you can use it, or if at all it is you can represent a parametric equation. So x, y and z values can be written in terms of theta and phi. Okay, the theta is distance from x axis, and phi is the angle between the horizontal axis and the actual r. So considering these things, you can easily represent a sphere. All the points on the surface of a sphere, they can be easily found. How? You will have to range the value of theta and phi accordingly. Ellipsoid is also similar thing. The similar equation, it is circle and ellipsoid, only the difference is the equation is, earlier it was x square directly, here we are writing earlier actually r square was for same for all of them, right? But now what is happening, the radius is different in all the directions. So x upon rx square, y upon ry square, z upon rz square is equal to 1. Parametric representation is also similar. Earlier r was same for all, now the rx, ry and rz are separate for all x, y and z. I believe similarly other whatever object we want to draw, they will have their equations, we can use them. Let me now talk about some spline representations. Okay, I will talk something about a spline representation. We are talking about spline representation. What we considered is 4 points here. These 4 points, you can easily understand that in English alphabet it was C. However, I proposed to represent it in a different way, not the exact line terms, but in a curve. Starting point A, B, C, D. So this is the first curve. Let me call it some other name. It should be T1 and this is T2. So this T1 curve is from A to D. However, you can understand it is not crossing the B and C. So this particular curve T1 is being called as approximation, and the other option, we are going from A and also moving from B, C and D, B, C and then reaching D. It is considering all the intermediate points. Then such kind of curve will be called as interpolation. What you are doing is, given the points, you are using these points and generating a curve. Okay, this will be considered as interpolation. And another option is, you are generating a curve but you are not bothered of crossing all the points, but more bothered about the curve itself. Okay, so such kind of thing will be called as approximation. One thing in common that you have seen is the end points has to be considered always, whether it is approximation or a interpolation. So having talked about this, let me tell you about suppose this was a C. Now let me consider this thing. Okay, these are the 5 points. Okay, if at all it is visible or not, let me take it bigger ones. So these are 5 points. What will be the interpolation? If at all it is interpolation, it will have to cross, it will start definitely from here, it will have to cross from all the points. Okay. However, if at all it is a approximation, in that case it need not go through all the points. It can be something like this, which will be more smoother. However, it may depend whether you want this thing or this thing, depending on your applications. Okay, some of the things, let me tell you about the names. One is Hermite, we call it interpolation. Hermite interpolation. Okay, what they are saying? They will give you a set of equation. Okay, suppose they will give you what is they will call it some p values, p0, p1 and different other values. Suppose pu okay, which is equal to something, okay, several things. This will give you an equation. Using this equation, you can generate a interpolated line. Okay, these equations can easily be found in the book, as well as you can, if you can use the these functions, no problem, it is already available. If you want, I can write also, but it will take much time. That much is not required actually. So similarly, as it is for interpolation, you can have a Busier curve also. Okay, in place of Hermite interpolation, you can have Busier curves. Okay, these are actually approximation. Here also you will have an equation, whatever they will say, pu is equal to something. You have to use this equation only. Okay, on and apply on the points, you will get an approximation. What they are saying is, in place of Busier curves, if you are using, we are calling it B-spline curves. Okay, it will also have an equation, but this equation, whatever the result is coming from B-spline curves, they look more realistic, more beautiful than the Busier curves. Both are approximation. Okay. So one thing that you have to understand here is, given the points, if at all it is interpolation, in case of interpolation it has to go through all the points. Okay, in case of approximation it need not go through the points, it will be approximated. However, the endpoints will remain same. Always the endpoints will be considered. The whatever the curve is displayed, this curve needs to pass through the endpoints. So the only two things are interpolation and what we call it, approximation. Using these you can definitely have surfaces. Okay. Now you can understand, while designing the certain objects with a smooth surfaces, okay, objects with smooth surface. How can you have a smooth surface? Using such kind of equations, whether it is Bezier curve or B-spline curve or a Hermite interpolation. In all these cases, you will definitely have your polygon meshes. Suppose you have made like this. Okay. Usually you can see when you design a car or something, what is happening? You will have these nodal points. These points are there, and you have to represent it like that. Mesh in a mesh design. However, later on, then what you can do? You can start making. Suppose these are the points you will have to consider, right? In that case, from here, and what are the point you will have to consider? Suppose this also. So let me make a little bigger one. I am making, yeah, it should have been straight anyway, so that later on when it will consider to make a curve, it look smoother. Considering these things, it can itself make a smoother these things, whether it passes through it or not. Now it will look, whatever the object will come out, it will look smoother. Okay, so then it will be earlier given the points, you are using the equation, it was a curve. Now you are using a mesh of curve and making it a surface. So it may be a Bezier surface, a B-spline surface, whatever you consider, right? Whether it is an interpolation or a approximation, it may be Hermite, Bezier or B-spline. So that is the thing. So here we have talked about it was Hermite or Bezier, it was interpolation or approximation, and we also considered that B-spline curves are little better than Bezier. Why? Because what happens in Bezier, suppose here you can say what happens in interpolation, it goes through all the points. What happens in Bezier, it does not go consider about these things and comes from here in between, right? But if it is B-spline, it is more realistic. Let me change the color. It will go little more near to the points. However, need not go to the points. It may, sometimes it may also go to the points if at all more number of points are here. Okay, so in order to cover them, sometimes it may go through the points also. So such kind of curves may be there. That is the case of your interpolations and approximations.